Hello, Data Voyagers. I am Igor Alcântara, and I am here today to talk about artificial intelligence. But I'll talk based on a different perspective. So this is a video where I will explain in simple terms, and I'll try to make it as short as possible, although it's not going to be too short. But attached to this video, you can check in the description the link for it. I also wrote an article where I will break it down in more detail, but it's still in simple terms with a lot of rock and roll references. And by the way, the design of this presentation is 100% inspired by Pink Floyd, not a brick on the wall. But anyway, let's get started. And when we talk about AI, you might think of what? ChatGPT, maybe Gemini, maybe Midjourney. So you're thinking on technology, they're kind of new. But artificial intelligence development began in the 1950s. So why only now it became so popular? I remember when I started studying this more than 10 years ago, in the beginning of this century, everybody thought it was something like sci-fi, impossible, never gonna happen. But now here we are. So what happened? Well, what happened was a paper, which is this one I have here, and also put the link for the paper if you want to read the original. It was a paper published in 2017 by Google Brain researchers in collaboration with the University of Toronto, Canada, and they developed a new methodology, and we call them transformers. The actual name of the paper is Attention is All You Need. And I always thought, that John and Paul, George Ringo taught me all you need is love. Well, maybe you need love and attention according to this paper. And it was a big game changer. This paper from 2017, so very recent, is actually what made possible for AI like ChatGPT to be developed. So let's break it down, this paper. So this is the first article of this kind where I will break down science papers and explain it in simple terms. If you like it, let me know. If we get enough views, I might do other papers, not only AI related, science in general, who knows? Let's see where the future leads us. But before we discuss what is attention transformer and how this works, let's understand what happened before, what we had before this. So processing of language, we call natural language processing, before transformers were made by neural network. So we have many types of neural network. We still use them for many things like image processing, audio, etc. But back then, it was the most advanced option we had for language processing, especially two types: the recurrent neural networks and the convolutional neural networks. I'm not going to break down how they work here because I'm explaining that better in the article text. Again, you can click the link to understand it. Again, in simple terms. However, what I want you to understand, these technologies have two main problems. One was super slow. It consumed a lot of resources like CPU and memory. Also, they consumed, because of the resources, a lot of electricity. The second problem is they could not handle well complex tasks in terms of language. So if you have like a long sentence, so at the end of the sentence, the neural network could not understand well the relationship of the beginning of the sentence. So you might think that when you're talking about something that who baked a cake, and at the end of the sentence you're still referencing the cake, but we might think that you are baking a person. I don't know. Long sentences and sentence like we Yoda like to talk like in reverse were very complex for these technology. Then it came this paper. And the main, concept around this paper is the concept of attention. So it's like all the neural network for language had ADHD, and this new paper does not. It was treated for that condition. So attention allows you to focus on the most important words in a sentence, and then you understand the sentence better. So the sequence of words do not matter. It matters, but not as much. What matters is the function of each word in the sentence and how they relate to one another. So if I see, and this image that we see on the slide, actually, I think right here, were actually extracted from the original paper. So in the sentence, for example, the law will never be perfect. What will never be perfect? Well, the law is really easy to understand that if we have the attention, because each word will have its own meaning, function, etc. in the sentence. So because it does not read in order, then it focuses on the actual function of the word and how they relate to one another, as I explained. And each word has a relative importance to other elements. So law has a higher importance to perfect than, for example, to be or to never. So it's all mathematical. Now, how does attention work? So we have three main concepts we need to understand: query, key, and value. So each word carries these three properties. So query is a question that you ask. For example, what is this related to? For example, if I say Sarah baked a cake and decorated it with cherries, what it refers to? So that's the query, is the question you ask to that specific word. And the key is a unique identifier of that word in the sentence. It identifies what is the function of the word in the sentence. Like in the sentence, the dog chased its tail. Dog is the main subject in the sentence. We're talking about the dog, not about the tail. So we talk, or the chasing, we're talking about the dog. So that's the ID or the key for the dog in that sentence. It might be different in a different sentence. And the value is what the word actually means in the context of the sentence and overall. Like, what is a dog in that example? So the dog, it's an animal, is a living being, it's a noun, it has a tail, so then we know tail and dog have like a higher correlation, a higher relationship among one another. So this is very briefly, again, I'm trying to break it down in simple terms how this works. Now, I also mentioned transformer. What is a transformer? Transformer uses attention and other techniques to create a module to interpret language. Not only language, we have variations that we can work with images and audio, for example, but the main focus to start was text. So transformers use attention as the main mechanism instead of other, like order of the words, for example. So then we no longer need the recurrent and convolutional neural networks to work with natural language processing. And the transformers, they have two main parts. The encoder, it's the one that processes the inputs, and the decoder, the one that processes the output. So look at this example. I have a sentence in English: Optimus Prime is a cool robot, and then I want to translate it like for Chinese, and I don't speak Chinese, so I'll translate it to Portuguese. So the way it works is Optimus Prime is a cool robot, then I process into encoder, so I do all of the attention mechanism that I described, and then other mechanisms as well that I'll explain in a minute. And then when I will decode, I'll decode to another language which has its own attention mechanisms, and then I get the sentence. It's a much better translation because it gets not a translation word by word, but it gets a translation, it gets the words more related in terms of probability to other words, so it builds human-like sentences. So then we'll get Optimus Prime is a cool robot, and encode and then decode as, for example, Optimus Prime é robô bacana, legal. So that translation using that, it identifies the words that could not translate because they are proper nouns like Optimus Prime, and identifies the one who could translate, identifies like who could be translated in many different ways in Portuguese. So it shows like the proper way in that sentence based on the context and meaning. So that is all possible because of the transformers architecture. Now, it gets even cooler, it gets even better, because we also have this concept called multi-head attention. So use attention in a multi-layer perspective. So it's like you have multiple language experts, and each one of them will analyze a sentence based on a different perspective. So let's say I give you a sentence: the young boy threw a red ball over the tall fence. So if I give this this fact or this sentence to different people to analyze, so if you live in the house that had the fence, then you might be focused on the fence, or you might be focused on the characteristics of the fence, that the fact the fence is tall, not short. If I give to somebody else, they might be focused on the boy because they're the parents of the boy, or I don't know, if I'm the boy, maybe I'm thinking about the ball, or if depending on who I am, I'm thinking about the color of the ball, or maybe I'm thinking about the action of threw. So depending on who is analyzing this, I will focus on different aspects. So that's multi-head. Each one of these aspects, each person analyzing, person quote here, it's a different head. So let's say person A will focus on the action through, a person B will look at the colors like red, description, tall, and person C will think like who's involved. Is there a person? Oh, there's a young boy involved. So there's a multi-head. And sometimes you focus on the grammar function in the sentence, and another head or another layer will focus on specific characteristics, another on time, etc. Again, in the article, I'll break this down in little more details. There's no math, there's no complicated stuff, but with more details. And then finally, we have positional encoding, because I mentioned before that transformers do not use order or not use order primarily to do its job, but order matters. So if I have this sentence like the cat chased the mouse, that's different than the mouse chased the cat. They are the same words, but I just changed the order and the meaning is totally different. So of course, position is important. So we have a mechanism in the transformer algorithm, transformer model, called the position encoding. So each word in a sentence gets a tag, basically is associated, is like a GPS coordinate with its position in the original sentence. Like D is the first, cat is the second, chase is the third, mouse is the fourth. So that gives the module a sense of sequence. So then you can reconstruct and break down the sentence and understand meaning, like who chased who. But also it helps build relationships between words, because sequence, it's not the most important, attention is, but it still is important. Now, this has real impact. You probably read, hopefully actually, you read some of my articles about Qlik Answers. Qlik Answers, it only exists because of this paper, because it lives on top of Anthropic Claude, which is a large language module which is based on transformers. You like ChatGPT, so the T in the GPT stands for transformer. And other technologies like the Google Gemini, for example. So we only seeing the beginning of this revolution. So this paper will probably be remembered for many, many years as the real game changer. It matters a lot, even if you're not using AI, you've been impacted by AI most likely. And if not, you will be soon. So that's why I decided to bring this today. And if you want to know more details, again, check the description of this video and click the link to read the article. It's not long, it's not complicated. I just give a little bit more detail and a lot of rock and roll references. And if you like this video, Please like it, share with everybody you know, and leave your comment. Thank you. See you next time.